it's only one station away from 61. Does everybody see that? What do you use for E? 7. That doesn't change. What do you use for T? 4. That doesn't change. So what do you get for the tangent offset at station 62? Matthew says 1.75. Matthew changed his mind, says 2, and then Matthew changed his mind again, said 0.44. No, I think at station 62 is 1.75. Yeah. Does everybody follow that? At station, okay, at station 62, it's 0.44. Matthew says 0.44, and several of you are saying 0.44. Amjad says it's 1.75 at station 63. Guys, this is a very popular question, tangent offsets, and it, as you can see, it's not that difficult, so please learn it. Now, parabolic curves are symmetrical. So everything on the left-hand side would be a mirror image of the right-hand side, regardless of these G values. Gradients are different, but the tangent offsets on the right-hand side and left-hand side would be the same, all right? Now, the next thing that you need to do, they will ask, for example, what is the station, at station 64, which would be here, what is the elevation on the curve? So what do? Pay attention. We take the elevation on the grade line, in this case, subtract the tangent offset, subtract the 3.94, and what do we get? Whatever we end up with would be the elevation on the curve at that station. And here it is. See these bottom lines? The values on the bottom line. These are elevation along the curve. And I hope that you understand how each one was obtained. Now, I have to tell you, they will not give you a comprehensive problem like this asking you to calculate all of these values. They will only ask you selected ones, all right? But that's the process. Let's move on. Okay, here is another concept. Brian, I don't understand your question. Here, this concept of the highest and lowest points on vertical curve. This is also something that you're responsible to be able to do. You know, these vertical curves have either a high point or low point. It's important for us to know for clearance or for drainage. Two things. Where are they located? And also, what is the elevation of the high point or the low point? So, what I'd like for you to do is these kinds of problems, I need for you to solve them using this equation. This is a very, very straightforward, simple equation. And x is equal to minus G1 over R. G1 is the gradient of the first tangent, back tangent. And remember, if G1 happens to be negative, this would be negative of a negative, all right? So make sure that you pay attention to that. And what is in the denominator, that's R, which is the rate of change of grade. Rate of change of grade. I gave you an equation for it. In fact, guys, that equation is right here. All right? So if you're asked to find the low point or the high point, use this equation, calculate R. In this case, R comes out to be minus 7 over 8. Substitute R, and X comes out to be plus 4.57 in terms of stations. I need for you to pay attention and understand what this X is. This is not the elevation. This simply tells you how far away in terms of stations is the point that contains either the high or the lowest elevation. All right? So this equation just helps us locate that high point or low point. Todd is asking about the length L. The actual length, Todd, is in feet. For example, 800 feet. But in many of these equations, as I have explained, um, we are expressing that 800 feet in terms of stations. All right. Now this X comes out to be, in terms of stations, 4.57. So the actual station comes out to be 65 plus 57. All right, that is, pay attention to how we got that. It's 61, which is the station of the PVC. We added 4.57 stations to it, so we end up at 65 plus 57. That is the station of the highest point on that curve, this curve that we have been working on. All right, so the next thing, once we know the actual location of the high point, then we need to be able to find the elevation. Now, this equation down here, this is like Prego sauce. It's all in there. What I've done here, I have combined 3 different steps into one equation. If you don't follow exactly how that equation was calculated, please allow me to show you page 71. This is what I have broken it down into step by step. All right. Once you know exactly where the station of the high point is, this is what you need to do in order to find the elevation at that point. All right. Basically, I'll tell you. You identify the location, then you find the elevation on the grade or the gradient line, then you subtract the offset, calculate and subtract the offset from it, and it gives you the elevation on the curve. Follow that on your own, and if you have any questions, let me know. Problem number 8 is a typical vertical curve. I will leave this for you to review. Use this to practice what I just showed you. The next topic that we're going to cover is the sight distance. There are 2 more topics that are very important for the test that I will cover before we stop. This is the concept of sight distance, and then the next concept I'll cover today is vertical clearance, which is also a typical class of problems. We may go over time about 5 to 8 minutes today, if it's okay with you guys. Let's talk about the sight distance. Sight distance, minimum sight distance, is for safety on vertical curves, and there are different ways of calculating the minimum sight distance. But here I am using this one equation that I promote and I ask you to use. It's rather simple once you understand what the different parameters are. By the way, this S on the left-hand side, that is the minimum sight distance. That's what we're calculating. 8 is an 8. L is the length of the curve. H, guys, pay attention to what that is. H in that equation is the height of the driver's eye above the pavement. In other words, your line of sight, how far is it from the surface of the pavement? We usually use a number, 3.5 feet to 3.75 feet. Think about what that represents. With the SUVs that are so common these days, the higher value, 3.75 feet, is more likely. And in calculations, that's what we use. But you could go anywhere from 3.5 to 3.75. In fact, you can do this, whatever vehicle you drive, you can measure that for your case. When you're doing it, make sure nobody is around seeing you do that. But you can actually measure that. And then in the denominator, basically, G1 and G2 are the same thing we've been talking about before. Let's move on and see how we can apply this to this particular curve we've been talking about. By the way, L was given to be 800 feet. G1 plus 4%, G2 minus 3%, and H, as I indicated, told you what it is, and we're going to use 3.75 feet. For that. You substitute everything in here, but I have to point out something very, very important to you. In this particular equation, the length of the curve is expressed in terms of stations. Please make a note of that. That's very important. So the length of the curve in this equation is expressed in terms of stations. So if it's 800 feet, you use 8. In here. You do the calculations. S, by the way, the equation gave you S squared. Well, we really don't need S squared. We need S. That's why we have a radical on the right-hand side of the equation. And then S comes out to be 5.8554 stations, and S in terms of feet is 585.54. So that's the number, but let's understand what this represents. This is the minimum sight distance for this vertical curve. So we calculate that, and then they may say, is this curve safe? Well, this is how you decide. If this S value that we just calculated, if this is smaller than the length of the curve, then that curve is indeed safe. Now, this S came out to be 585. The length of the curve is 800 feet, so we are fine. Now, what if you calculated this S and this value came out to be higher than the design length of the curve? Well, that vertical curve, if that's the case, then that vertical curve is not safe, and then what you need to do is to go back and increase the length of the curve to make it safe. Next, let's move on. Okay, this particular problem, this is the last concept that I want to share with you, and this deals with the concept of vertical clearance. Vertical clearance, which you're responsible for, all right? So let's see what we can do here. Read the words here, but what I need to point out to you is this. They say the proposed alignment must bridge over an existing railroad track, and this railroad track crosses the proposed alignment at station 28 plus 50. So far, so good. However, pay attention to the next line. The next sentence says the elevation of the railroad track at the point of intersection is 195. The proposed highway alignment must have a vertical elevation difference of 26 feet at station 28 plus 50 in order to satisfy vertical clearance requirement. This is your clue, guys. It says to satisfy vertical clearance requirements. And you can read the statement of the problem later with more care, but that problem reduces to this. Once again, these are common problems on the test. So here's what we're looking at. In order for this is the issue here. In this particular case, you must have a clearance of 26 feet from here, which is the bed of the railroad track, to that curve at that point. All right? So you must have a clearance of 26 feet. Let's think about what we have, guys. What we know, Benjamin, what you say is correct, yes. The elevation down here is 195. Now, let's take a look at this step by step. The elevation at the railroad bed is 195. The clearance must be at least 26 feet. So, knowing that, what is the elevation of the curve? What elevation do we need the curve to have at that point? It's 221. That's the way we got that is 195 plus 26. All right? So that's 221. So it's a clearance problem. But please pay attention to what I will say next. This problem now basically reduces to forcing the curve, think about it, forcing the vertical curve to have a specific elevation at this point. Now, what is that specific elevation? It's 221 feet. All right? So this problem reduces to somehow forcing this vertical curve to have an elevation of 221 at the station 28 plus 50. All right, if you accept what I just said, then let me share with you an equation that I will present to you that will help you calculate what you need very easily. This equation, guys, can be used to force a curve to go through, a vertical curve to go through a fixed point, and that's exactly what we're doing here. This curve I found in a very old surveying book. I have misplaced that book, and I really don't know the reference for it, but it works simply and very easily for these kinds of problems. Let's take a look at it very carefully. L is what we're looking for. All right, that's the length of the curve we're designing for. Now, the ingredients A, capital A, I will tell you what that is. Offset, the word offset is used. That is nothing other than the tangent offset that we've talked about so far. And then the only other thing that shows up are G1 and G2, the gradients that we've talked about before. All right, now, what I need for you to do is understand what we are using for the value of offset. In this case, offset, we're using 2. I'm going to flip to the previous chart to tell you where we got the 2. The 2, guys, pay very close attention. That's the offset. This is it. All right? Make a note of it. That's simply the offset, tangent offset at the station that you're interested in. All right? So it's the difference between the elevation of the tangent line and the curve at that point. It's simply 223 minus 221. So that's where we got the 2. That's the offset. Now, what about A? Capital A. Now, a lot of people have difficulty with that, but that's simple. Write it down. A is simply the distance. I need to go the other way. A, now, pay attention. A is this distance between the station that you're interested in and the station of the PVI. All right? In this case, the station 28 plus 50 minus station 26 plus 0. So what do you get? 2.5 in terms of stations. Did everybody see how I got that? So A is the distance in terms of stations between the station you're interested in and the station of the PVI. And in this case, comes out to be 2.5. And then G1 minus G2 is 5. Make sure preserve the algebraic sign. All right? So substitute those values into that equation. The answer you get, the answer you get becomes 10.91. All right? So we get 10.91. When you solve that, you get 10.91. So the correct answer here will be 1,000 feet. All right, so 1,000 feet is the answer. Now, a lot of people here, they ask me, they say, why didn't you go above the 10.91? In other words, you didn't choose 1,100. Why are you going to 1,000? Well, because that clearance, we need to know, I need to go the other way, because we need to have at least a minimum 26 feet. All right? The longer the length of the curve, the flatter the vertical curve becomes. So to ensure that we have at least 26 feet of clearance, we need to make it shorter. All right? Ryan says, did you just make up the offset? No, the offset is the distance between the elevation on the tangent line and this elevation on the curve. 223 minus 221 gives you 2. All right? Christopher says, where do you get the 223? The 223, it's either given to you or, look, you can get it from this information right up here. All right? You know the gradient of the forward tangent. You know the elevation at PVI. You can calculate that elevation of 223. Let me know if that answered your question. All right, you got it? Now, so there it is. The answer is 1,000. Then the next thing is, can you find the station of the high point and the elevation of the high point? I leave that up to you to do. We're running out of time. This problem 11, I did not plan to go over the solution of this, but this is also a clearance problem, but this is slightly more complicated than the previous one. So I would recommend just do this one if you're taking the transportation exam in the afternoon. All right, it's the same concept, but it requires trial and error solution. All right, but the complete solution is provided to you. These are the references that I've used for this particular presentation. I hope that you found this presentation helpful. And again, do as many problems of this kind as you can get hold of. And many people have given me feedback. This document that I have put together for you, this presentation, this is very helpful to you on the test, and many people have just used these problems and this handout